Let's start this video with a couple of questions. Question number one. What would you call a machine with an integrated power source of its own that runs continuously and doesn't require any electrical or fuel input? Unusual? That'd be a reasonable definition. Question number two. What would the COP of such a machine be? Let's see. We've got rotary torque plus a little electrical output divided by zero input. Infinity? Now, how about coulombs of energy accumulated over a 40 or 50 year period? Maybe that would be a good way to. Oh no, that doesn't do it either. See my point? Okay, I know some of you are going to say, but your power cells are your input. No, I said that they're an integral part of the machine. It's a fundamental piece of the machine itself. That's like saying, hey, I got a good idea. Let's take the coils out and see how fast it runs. Well, it's not going to run at all. All right, how about the magnets? Let's pull them and see what kind of power it can deliver. Well, it's not going to do anything. Okay, then let's take out the power cells and see what happens. Again, nothing. It's all essential parts of one machine. This requires zero input. It's an essential part of the machine. Okay, now a brief explanation. The power cells, you can see there's six. They're individual, and there's six of them, and there's 6 ultra caps in this module. Each one of these power cells is assigned to one ultra cap. Each individual cell to an individual ultra cap, and then the ultra caps are connected internally in series. All I did is I put the wires in where the resistors come out that bleed off the cells for safety purposes, and so that they will constantly feed these cells. Now I'm going to show you later in this video something interesting about taking this ultra cap module off. But for now, let's just use it and go through the explanation of that. So that's what it does. This will give you a higher voltage output by doing it that way. And you can really speed this thing up. You can see that by turning the potentiometer, I'm bringing in more current. And it's obviously going to speed the machine. I don't want to max it out. It just hums when you do that. There's more power in these than you realize, and we're going to go into that. I'm going to give you a complete rundown of that. So stay with me. Okay, the next demonstration for the Q beta prototype is going to be regarding a little bit of torque. This is my G1, and you can see over here all the switches are off. There's no power to it. It doesn't engage if you turn the rotor. It's off. The only idea is to see if this unit will power this unit, will start it from a dead stop. There's over 30 pounds of rotary weight on there, so that's quite a feat. I've got the jaw coupling on here, so let's turn this on, give it a little power, and I'm just turning this from a dead stop position. Right now the needle is pegging the 1 amp point. It's kind of where I want to start. I don't want to push any more amps than that. It can do that, by the way, but you'll see that later. But I just want to get it going, because once it gets the rotary motion, then the current comes down like any typical motor would do. The point of this demonstration is to show that the comments that I get sometime about pulse motors having no torque it's really bullshit. They do. You just have to have the right design, and this is the right design. Now, speaking of the design, this unit is not designed to do this on a constant basis, because it would take a few more panels down here to keep up with the demand that is being put on this machine to run this much extra kinetic load. But it's a good demonstration, and I wanted to show you that. Alright, it's in my nature to save the best part for last, so if you've stayed with the video to this point, you're going to be glad you did. I'm going to answer the questions that everybody asks. Firstly, how much power can these panels actually output on their own? And what are they made of? So I'm going to answer both those questions. So here we go. Now here's what I've done. I've disconnected. These are all the positives to the ultra caps. You know, one cell per ultra cap. Then down the next times 6. And down here is there's all the negatives that go to the cell. So I've taken those all out and I'm putting these patch cords in there, and I'll show you up close here. I've put these little copper pieces in between here. So these are in parallel, these two are in parallel, and these two. And then those 3 pairs are connected in series. Now the only reason I did that is so I can get a little bit more current out of putting 2 of these together, and also get enough voltage to run the pulse motor, because you need at least a few volts to do that, or more. Preferably, you know, 12 volts to 24 volts, something like that, and this thing will run like a scalded dog. But it'll run with this, and I want to show you what it's going to do. Now over here, let me zoom back in a little bit. Sorry. Over here, you can see that the connections. Here's the negative here, and here's the positive, which the negative goes here, positive goes here. So they're out of there, and I've just got the patch cords, and the negative goes down to, there it is, goes down to here, and it connects down to here, and then the positive up here again, because these are in series parallel actually. So what we'll do is I'm going to show you, I'll have you take a look at the meter, and you can see what kind of current comes out of these things as they first start up. So let's zoom in just a little bit on that, and I can spin this around a little bit better so you can see that meter. That's pretty good there. Okay, so now I'll come over here and just give this a light spin. So just kind of keep an eye on the meter and see if we get a couple hundred milliamps or what. There it goes. Well, it pegs well beyond the 1 amp capability. The reason I'm using the 1 amp meter is because once it gets the rotation and the pulse duration cuts down, obviously like every other motor, it starts drawing less current. But you could see that it actually pegged the meter for the first 2 or 3 times. And I'm going to show you what is actually beyond that 1 amp peg, because some brilliant scientists told me that I'd be lucky to get maybe 30 milliamps out of one of these cells. And so we're going to have a look and see what we actually do get, and then we will know. Now before we do that, I'd like to note just a couple of things. Number one, you can see on the meter that each pulse is a half an amp or just a little greater, and I've got 2 pulses per rotation on the timing disc on the other side here. So that's what you're getting on each pulse. The voltage is probably about 4 or 5 volts. It's not a whole lot, and again, it's because of the series parallel connection of the panels. We could get a greater voltage, but then the current changes. So I just like this particular one, but it'll operate in a lot of different settings. So I wanted to let you know that. And here, what I've done is I've adjusted the potentiometer over here, so it's not even drawing the full power that it can from the cells into the pulse motor. So I'm gonna show you that. What it actually can do. I'll show you even on a dead short exactly the kind of current that comes out of these panels when you do that. But the other thing is, with it set up like this, this pulse, it'll go like this pretty much continuously. So in other words, well, I've had it running for many days in this configuration without going through the intermediate ultra caps or batteries of any kind, just so the cells themselves can do all the work. Now it's not spinning super fast, but there's still a little bit of torque there, and the fact that it can even do it, and do it 24 hours a day, day in, day out, for who knows how many years. These things, you know, this is not your high school project variety of crystal cells. I'm going to go into what they're made of, and explain to you the major difference between these and your little copper tube varieties that people have been playing with for numerous years. Okay, now I've disconnected the positive and negative to the inputs over here, and I just want to show you again, if you can hear this, watch the meter peg and listen to it peg. Okay, so you can tell it's producing way more than an amp. So what I've got, let me set these down. What I've got is I've got a 3 amp meter that I will change the little patch cords going to the meter here onto this one, and we'll see what it does with the 3 amp meter. I'll be right back. Okay, all set now, and just so that you're not in the dark, let me explain what I've done. I've got all of these connected in parallel. You can see the little copper strips here that just join the brass connectors. They're in parallel up there, and they are also, you can see, they're in parallel down here as well. And of course we're still disconnected from the ultra caps, so there's no power coming in from anything but just the cells. Here are the 2 cables. Now what I've done is I've put this 3 amp meter, set it up there so that you can see. We'll put a dead short across these and you can watch what the meter does. Let me just keep it right there for a second, and here we go. It pegs the meter. So unfortunately I put these 3 amp meters in just about every machine kit that we manufacture, and I don't have anything greater than the 3 amp. I probably should have had maybe a 5 or 10 amp meter, because I have a feeling that we're pulsing maybe, I don't know, it's pegging it. You can hear it. I don't know if you can hear that. Can you hear it? Anyway, it hits the 3 amps and hits it hard, so maybe we're producing 4 or 5 amps, I don't know. But 4 or 5 amps out of these 6 cells. Now the cells are 12 inches square, so they've got some area. And I'm going to explain to you why, and it'll do this over and over. I don't care if you sit here for the next week or two or month or two. It's going to, look at that. You hold it there. Okay, watch, I put it on a dead short. Watch the 3 amp meter. It's going to burn it up if I hold it any longer. Okay, wait a minute, here we go. Ready? Oh, shoot. It's a bad little boy. Okay, so that's what we actually have. And again, you know, you can see there's nothing else connected. It's just these panels themselves that are doing all that. All right, let's just say it only produces 3 amps. Well, obviously you know that it's doing 4 or 5 amps. Who knows? Maybe even more than that, by the effect of slamming the end of the meter. So let's just say it's 3 amps. If I can make 3 amps, I can make 100 amps. And if I can make 10 volts, I can make 110 volts. You get my point? That's 11 kilowatts. What do you think you could do with pulsing 11 kilowatts? Maybe a Tesla Powerwall or 2, if they could even handle it. There's where we're going with this. This is going to be utility scale power. People just don't understand how it works, and now I'm going to explain to you how it works. Okay, I've removed the little copper strip bridges just so you don't have to look at their ugliness anymore. In fact, I can take this meter off too. It's just sitting on there. So zoom in on the cells. Let's go in instead of out. That'd be better. All right. Okay, here's the explanation of what we've got. All right, there's 2 plates that you can see. There's 10 elements altogether in every single cell. 10 elements. It's a tedious process of fabrication of all the things, of the 8 elements inside between these 2 plates. So you've got, and I'll cover that in just a second. So initially you start with a redox reaction, a very light redox reaction. You've got a donor plate here on this end, which is your anode, and this is your cathode here, which is a very high grade of graphite. It's a breathable graphite. In fact, when the cells get overworked, they will actually sweat through the surface. It's interesting how in the world it does that. This material is 1/8 of an inch thick. It's absolutely fascinating. Okay, so anyway, you've got your anode and cathode. So your anode wants to oxidize and give off some electrons, and the cathode is ready to receive them. But what does it have to go through? All right, I've got a dielectric electrolyte in there. It's in the form of kind of a sticky gel, for lack of a better term. They think of it like that. It's a sticky gel formation which also has silicon crystals inside that gel. Now, silicon, when it's activated electrically, can expand up to 300 times its normal size. That expansion has to go somewhere. That's been the problem of everybody. Where in the world does that expansion go on the silicon once you activate it? Because it increases the charge carriers, which allows the electrons to flow from plate to plate faster or at a higher rate. So if you don't have some kind of a mechanism to take care of that expansion, you're just going to get fracturing. And fracturing is going to destroy whatever you're doing, the cell. It's going to destroy the cell itself. So where does the expansion go? It goes in the gel. Yeah, it's as simple as that. It goes in the freaking gel. Okay, so that expands. The charge carriers increase. The growth, goes crazy on the silicon, and here comes the electrons from the donor plate to the cathode, from the anode to the cathode. Now it goes through the. Let me explain one other thing before I go any further. The gel is also like a fire retardant. These things will not burn. They will not freeze. It's very fascinating. It's all eco-friendly. There's no acids. There's no toxic chemistry inside there. It's just that this is the dream I've been waiting for my whole life, and I'm in my early 60s, so that's living the dream for a long freaking time. And here we are, but this actually works. So it goes through the dielectric electrolyte, that sticky gel material, and increases the charge carriers in silicon, and then travels over to the cathode here, and before it gets to the cathode, it goes through a large capacitive layer, the same size as the cell. These are 12 inches square. So initially, you get a very large pulse of current because of that capacitive layer. That's that 3 to 5 amp burst you were seeing on the meter. And as long as there's a little pause in between, you give it enough time for the anode to produce more electrons to send and load up in that capacitive layer to burst. So pulsing is the way to go. If you run this thing, if you run these cells constantly with one continuous output, you'll bring the cells, the level of the cells will come down, but it will rest at a point. But that point may be a third of what the current capability is. Instead of, let's say if it was 3 amps, it's going to be maybe 1 amp. Now it's a continuous 1 amp, and that's cool, but still, I mean, with a couple amps more, there's a lot more you can do. So pulsing it is a critical point. And let's see, what did I miss? So that's pretty much it without explaining all the chemistry in between, and I don't really want to do that, but I want to tell you how it works and why it works the way that it does. And that's how it works. When you're not putting the cells under a load, the dielectric electrolyte has a tendency to shut down the cell. I don't know how to, it cuts down the redox reaction. In other words, there's hardly any oxidation, if any at all, that happens because that gel will retard that oxidation and protect the donor plate. Who has ever heard of that? There is nothing like these anywhere. I don't care who's working on what, nobody's got anything like this. And we need to go further with this. We need to produce this thing on a large scale. Everybody needs to have something like this. This, I see where this could be a replacement for solar. Instead of having the expense and the liability of panels all over your rooftop and then all that cost for installation and maintenance and everything, imagine a couple of boxes in your basement or garage that has these cells, and they're all connected and they're charging up something like I mentioned earlier, like a Tesla Powerwall or something comparable to that, or whatever, to to pulse 24 hours a day. If you're running something constantly, you've got to use like maybe 15 to 20% off the top of the production of these cells. So if you do that, the cells will never drop. They'll never drop. They'll give you that load, you'll power your load or whatever it is that you're doing, and they won't drop. They'll hold there and hold there, just like I was telling you that I run this machine for days on end just on these cells. Now, the caps are good. I mean, don't get me wrong. The ultra caps are good as an intermediary storage medium. It could be lithium batteries or whatever, but the ultra caps charge up fast. And they're good because when I showed you before, when you connect onto the shaft, you get a lot of torque because these can deliver to get a torque really cranked up. You want a lot of amps, maybe more than the 3 or 5 that this produces, and it's all stored here. Plus, you've got this series of all 6 of these, and they're these panels here that are hooked one to each other. You're only going to end up with somewhere between 6 and 9 volts off these, even though each capacitor is 2.7 volts capacity. That's just what these are going to produce. Now, granted, there's a need for more cells, and I'll touch base on that in a second too. But so this is good, but you can live without it. You can use it, or you can not use it. That's your choice. I just showed you what this thing can do, what it's capable of doing. So that brings us to another point. A new page on my website at quantummagnetics.com, and you can do a pre-order of one of these. We're going to do just a limited production so that we can get going on this, and I don't know how many will be there, but since it's going to be a pre-order, it'll be a first come first serve. So if you're interested in participating in the program, you should do it fairly soon, and we will do about a 6 to 8 week shipping schedule on these, because as I said before, the cells are very difficult to manufacture, to fabricate. There's a time sensitive process in the fabrication as well, so it's difficult. That'll allow us enough time, and we'll ship these out to you so you get good value, and the funds will be able to promote us to go further with this technology. The cells will now be sold separately, so don't even ask. It'll be a unit like this, so you'll be able to pulse and test it in a correct manner. So that's it. So we'll see you on the website, and if not, you've seen it here first.